Welcome to the next chapter in this course, where we are going to discuss the event-driven architecture. If it wasn't obvious by now, we were already implementing the event-driven architecture, and after going through this chapter, you will realize the principles and patterns of event-driven architecture that we were implementing inside of our modular monolith architecture. This is what we are going to talk about in the first lesson. I'm going to start by introducing the event-driven architecture, and we're going to explain what it is, how do you implement it, and what are some common patterns of event-driven architecture. We're also going to discuss the benefits of being event-driven along the way as we introduce the concepts of event-driven architecture, and we are going to wrap up this lesson with a short discussion about orchestration and distributed transactions. But let's start from the obvious and explain what is an event. An event is an immutable fact inside of our system. It represents something that has already happened, which means an event is in the past, and it also cannot be changed. So an event is an immutable fact inside of our system representing that something of significance has happened. A few examples of that inside of our event management system would be order placed, order paid, order cancelled, payment failed, tickets issued, and so on. The next question that we should consider is, what does it mean to be event-driven? When we say event-driven, we are mainly concerned with business events. Let me give you a few examples of that. Here are a bunch of examples of relevant business events inside of an event management system. For example, we have order cancelled, order placed on hold, discount code removed, attendee checked in, attendee checked out, attendee re-entry, event created, ticket type inventory updated, ticket type sold out, and a few other examples. So inside of an event-driven system, we have a concept of an event that is an immutable fact of something happening inside of the system, and we use these business events to facilitate communication inside of an event-driven architecture and trigger the necessary behavior as a reaction to the business event to produce the desired results. So an event-driven architecture is a reactive style of architecture where you react to incoming events instead of explicitly telling the system what it should do next. Being event-driven also allows us to produce a loosely coupled architecture where we could have one module, such as the ticketing module in this example, producing an event or a message which is published over a message broker, and then it can be consumed by any of the other modules that we have in the system. The ticketing module doesn't need to be concerned with the availability of the other modules in the system. It only cares about publishing the respective event. And then the other modules can asynchronously consume the published event. Now I'm going to introduce you to a few patterns of event-driven architecture, and you can say that your application is event-driven if you are using at least one of these patterns. And the first pattern of event-driven architecture is event sourcing. We also have event notifications, followed up by event carried state transfer. And lastly, we have the CQRS pattern, which stands for Command Query Responsibility Segregation. Before we jump into explaining these patterns of event-driven architecture, I want to make an important remark, and that is that you don't need to be using all of these patterns in all of your applications. You can choose to only use one of these patterns if they give you the benefits that you desire. And with that said, let's check out these patterns one by one. The first pattern of event-driven architecture that I want to discuss is event sourcing. And the main responsibility of event sourcing inside of an event-driven architecture is managing application state. So with event sourcing, you are going to model the persistence of your system as a series of events applied in a specific order. For example, take a look at this stream of events. We have an order placed event, a ticket added event, another ticket added event, a ticket removed event, and then an order paid event. You can imagine that all of these events will be accompanied with some respective metadata, for example, including the customer. When we are adding the ticket, we would probably include the quantity and the price of the ticket. And finally, when paying the order, we may want to include some payment information. And what event sourcing does is it persists the individual events as the state of our system. There is no table called orders or tickets. There is only a stream of events that apply to a particular aggregate, and you define the final state of the aggregate by applying all of the events inside of that stream. Event sourcing is, at least conceptually, a very simple pattern. All you have are a set of events applied one after the other to derive the final state of the system. However, modeling these events, managing their lifetime, versioning the events as your system evolves, applying projections are all very complex topics, and understanding them requires a completely separate discussion, but for now this should be sufficient for you to understand what event sourcing is on a high level. The next pattern of event-driven architecture that I want to discuss is event notifications, and you will realize that we were already using this pattern inside of our system. For example, here is a code snippet containing the order created domain event from our application. This event represents a notification inside of our system that something has happened. In this case, it is the creation of a particular order specified with the order ID property. And event notifications are mainly used to tell the other components inside of our system that something significant has happened. Another characteristic of event notifications is that they will usually be very thin events, meaning that they do not contain a lot of detailed information. In this example, we only have the order identifier, which is enough for us to handle this event, possibly fetch the order information if we need to do some further processing. The main responsibility of the event notifications pattern is communication between the various components inside of an event-driven architecture. Then we have the event carried state transfer pattern, which we were also implementing, and here is an example of the event published integration event, and you can notice that this event contains a lot of contextual information about the event and also the included ticket types in this example. The responsibility of the event carried state transfer pattern is data distribution between the various components inside of an event-driven architecture. In our example, this would be data distribution between the modules inside of the modular monolith architecture. Another very popular pattern of event-driven architecture is CQRS, which stands for Command Query Responsibility Segregation. And while my preferred way of implementing CQRS is on a logical level, inside of an event-driven architecture, we can also implement CQRS by using separate persistence mechanisms for the write side of our system and for the read side of our system. And we are going to use events triggered on the write side of our system to apply projections and update the read models inside of the respective read database. A very elegant way to implement CQRS is together with event sourcing, where you will be storing a stream of events as part of your write database and possibly inside of a dedicated database that can work with events, and then you would use this stream of events to build the projections inside of your read database. In our implementation so far, we have been talking about domain events and integration events. You can also think of them as inside events and outside events, or internal events and public events. My preference is calling them domain events and integration events, and the main distinction is how they are used. You publish domain events inside of a particular domain, bounded context, or in our case, inside of a particular module. And then you use integration events when you are crossing the domain, bounded context, or module boundary and you want to communicate with other independent components inside of your system. Event-driven architecture is very useful when you are building large business applications or complex enterprise systems because it allows you to build a very loosely coupled architecture and also a reactive type of architecture where your system reacts to the events that are being published instead of being told what to do. Here are a few use cases for event-driven architecture. You can use it for external integration between your modules or microservices. You can also use it to implement temporal decoupling, state transfer, and complicated long-lived workflows. Here's an example of how we could use event-driven architecture to implement temporal decoupling. In this code snippet, we have an order being added to an order repository, and then we have a request to the payment service to attempt to charge this order. This is an example of temporal coupling where we are waiting for the response from the payment service, which doesn't have to be available every time that we call it. So we need to implement some sort of error handling in case when the payment service is not available, where a possibly easier solution would be to apply temporal decoupling here. And instead of calling the payment service directly after adding the order to the repository, we could raise a respective event, such as order placed, which we can handle asynchronously, and inside of that handler we would call the payment service to attempt to charge the order. This would make the initial flow of placing an order simpler and also decoupled from the order payment flow. And if you didn't realize, we are already implementing this pattern using our domain events in the domain layer of the respective modules and then publishing these domain events using the outbox so that they can be handled asynchronously. Another excellent use case of event-driven architecture is orchestrating a complex flow inside of a distributed system. One component or service is going to become the orchestrator and is going to take up the responsibility of managing the communication between the various components inside of our system. This communication can be implemented using events and also using commands, which are just another type of message that we can send inside of a distributed system. The difference is an event tells us that something has happened and then we react to it, and the command is an instruction to do something. In this example, the ordering service could become the orchestrator for the order placement flow. And the first step would be interacting with the inventory service to reserve the inventory. The inventory service can respond with a respective event, and then we would continue to charge the credit card using the payment service and notify the customer using the notification service, and finally ship the order by communicating with the shipping service. The ordering service, being the orchestrator in the system, is the only one that knows what is the current state of the order placement flow, and the individual services only handle one part of the overall flow. Event choreography is an alternative approach to implementing orchestration. Instead of having one component that will communicate with all of the individual components, our system will just execute the entire flow as a part of individual steps. So the ordering service would create the order and then publish an order created event. The inventory service would react to this event and publish an inventory reserved event. The payment service would react to the inventory reserved event and publish a credit card charged event. Then the notification service can react to this event, send a confirmation email to the customer, and publish a confirmation sent event. And finally, the shipping service can react to the confirmation sent event, start shipping the order to the customer, and publish a shipment completed event. A common theme between all of the patterns of event-driven architecture is eventual consistency, and you will have to embrace eventual consistency if you want to build a truly event-driven architecture. And now let's take a look at how we are implementing some of the patterns of event-driven architecture inside of our event management system, and let's begin with the event notifications pattern.